Hello. I wanted to start with talk a bit about Module 4, since I believe that's roughly where you're at as far as submissions go, working on Deliverable 4 based upon emails that we've been exchanging and so on. Do appreciate the heads up on the fact that things have changed a bit on that resolver issue related to the Orange library. So what I'm trying to do right now is do two things at once, which isn't going terribly well. Attempting to launch Orange, it's not wanting to go, so we'll come back to that. But we'll start by going through, let me try one more time. But what I was thinking would be an appropriate sort of experience was to see it from a slightly different perspective, right? So we'll go through first and review Module 4. Then we'll talk about for looking at it from a perspective of using Orange to do the analysis, understanding though that you're to write Python code using the Orange library indirectly, but still kind of an interesting exercise, I believe. So jumping straight into the module overview. Rule-based classifiers. The basic idea here is that you want to have a means of determining rules, and you do so by essentially starting and do a decomposition sort of exercise. And the reason rules are nice is that people can understand them. You can look at them and understand the decision tree that's being constructed based upon the rules that are being inferred. And it's something that is quite explainable. That is an important part of discussions. In the previous conversation we just had was around how do you rate if a classifier is good or not? And one of those factors and facets is, can you understand it? Is it explainable? Is it intuitive? Does it make sense? And does it seem to be rational and explainable and appropriate? And what I'm trying to do here is get Orange up still. So while we're doing this, hopefully it'll go this time. I had Anaconda Navigator running for quite a while. Yeah, there we go. It's coming up. All right. So again, rules are a good thing. They help people understand why something is what it is. So the basic idea in this module of Module 4, you're learning how to do rule-based classification techniques. And this is something that does reasonably well a lot of times. They may not be good whenever it gets to overly complex things, but as a general rule, they do pretty well. We talk about the deliverable. This is about the IRIS data set. Right. So IRIS has been around for quite a while, and it's about being able to determine the species of a flower or whatever, the classification, the type of flower that something is based upon some measurements of its petals and flowers and such. So the basic idea here is that you're to load the data that's stored in a tab file. Tab is a proprietary thing to Orange. It's how it stores its stuff, and the key difference between it and something like a CSV is you can do things like mark what is the target, what are the categorical values, and so on. So it's a lot more expressive, but it is something that is kind of unique to Orange. Then, so you're to load it up using the Orange data table command to perform some exploratory analysis by taking a look at the first 10 lines, construct a set of unordered rules using the CN2, probably it should be unordered learner. One of those two is wrong, either ordered or unordered. So what I just caught, and I copied this out of the environment. So either this should be unordered or this should be ordered. So pick one, just document which one ever it is. I don't care terribly much because it's 2 lines or 2 spaces or 2 characters in your code. But anyway, pick one. Probably unordered is more appropriate. Then you use that classifier to predict the data of all the instances, and then print out the rules that are associated with it, and then print the accuracy and area under the ROC curve, which that's kind of redundant too, isn't it? The C, because that's what the C stands in ROC. Using the orange.evaluation.cross-validation method. And then what you need to submit is an executive summary that contains a description of the algorithm used to perform the computation. So this algorithm around creating the CN2 ordered learner, and the concept of inferring rules should be discussed. Then the results of your data exploration and a table containing the performance metrics along with a detailed explanation of how the metrics affect the results, and in addition to that, your source code, which is Python. The data looks like that. Those are the 4 measurements essentially, and the particular type of flower it is. So this has been around forever, and it is probably one of the most well-known data science data sets, and it is all about being able to classify flowers. And to me, I have trouble telling them apart, so it's not surprising that the computer might have a few challenges as well. Some resources related to it, and then the questions we'll come back to. So with that, I'm going to get out of presentation mode and keep up my instructions, and then this is when it'll probably go horribly wrong. So here's Orange, and it's always scary when we do live demos. The 4th project. And Orange has a tendency to open it someplace weird. Here we go. So this is not exactly what you're doing, but it's really, really close. So the first thing we're supposed to do is load the tab file. That's what this does. And you can see I am loading the files, the deliverable for iris table. This is the target. That's kind of the key piece that this lets you know, is so this tells the algorithm that's what we're trying to classify or predict. These are the 4 numeric features that contribute to that. Then to take a look at what the data looks like, the data sampler definitely, or the data table definitely does more than the top 10. If you wanted to be a real stickler and you only wanted 10 lines, let me think, how can we do that? Because we don't, it would be select rows, but the trouble is, what is that expression? No, you'd probably end up almost doing a data sampling is what you would do. That's what you do, is a data sample to get only 10. And we would say we want a fixed size of 10 instances. And with any luck, yes. Oops, drug the wrong thing. It keeps opening on my other window for some reason. So we get a data table with 10 rows. So to try to emulate exactly what you're doing, this is similar. Granted, this is probably random versus being deterministic, so that you know that which ones you're getting. So that's the first thing. Take a look at the first 10 rows. Then construct a set of unordered rules by creating a learner object. So we've got this CN2 rule induction is how we learn the rules. We have a choice here of saying if it's ordered or unordered, and so we're selecting unordered. And then there's some additional settings which aren't really specified in the assignment and are also likely accessible. I'd have to double check, but I'm pretty sure that you can set these other things. I left them pretty much with the defaults. Use the data and the learner object to create a classifier. That's what this predictions is used to do predictions. It's basically taking, this is the approach we always do of separating. So this data sampler, the real one, is basically creating a data set of 80% of it for training and 20% for testing. That's a common practice, and those numbers are actually fairly common as well. You could certainly do more of it, but the idea here is to have our holdout, and that's what this bit is here. This is the part that wasn't given into the training, so this is what we're using when we're doing predictions, and that's what we're using when we're constructing this area under the curve, or I'm sorry, the confusion matrix. Doesn't explicitly tell you to do a confusion matrix, but that's always a good idea. So anyway, so looking at my slide here, okay, we've done that part. We've done this part, creating a classifier, and we did some predictions. To print out the rules, let's see. Yeah, we've got the rule viewer here. Lets us see the rules. I've got it pretty limited, I believe, because it's not a whole lot of rules. But it does surprisingly well, and you can control the amount of rules by controlling how many things it takes to be the minimum number of elements that need to be covered by a rule. So if you decrease that, it's likely going to increase the number of rules. We'll say if there's 5 instances, it'll do it, and that should result in a few more rules, maybe one more, and it might actually move the needle on the confusion matrix potentially. Generally speaking, the greater the number of rules, probably the higher level of accuracy, also the higher potential though of overfitting, so something to be cautious about. I'm not too sure, yeah, this part I don't think I quite have right, but maybe it is, but it's, yeah, maybe it is. It doesn't really tell me the total number though, and this is by species or target. Yeah, I'm not too sure that part's 100% right. So on this part I've got probably close to the cross-validation evaluation. I don't think I have that one either. I'm not too sure that it's going to pop. That's probably the better approach to do it. But this, generally speaking, it's a different, let me see if I can get that to work by just sending the whole file to it. No. Yeah, the test and score is an alternative approach inside of Orange. It basically lets you do all this with lots of different classification algorithms. So it can similar to almost like a auto ML sort of experience, but not so auto. It makes it simpler, but it's still a fair amount of work. So the basic idea, this is where this library is coming from, is this element, and that's one of the cool things that's available or about Orange, is it does have both the visual aspect and also the library aspect. So it lets you do things like what I've been doing here of some simple visualizations, right, of seeing how the data looks like, which this is actually kind of pretty interesting because this lets you see along this particular dimension, a combination of petal length and petal width. It's really hard to get a good clean classification here, right? Because there's a line, if you were to stay in linear space, is not going to get there. You're going to have to go into some sort of higher dimensions. And the others don't necessarily help you much better. So it's about figuring out which would get you the best way of splitting things. And that one would be even worse than certainly in this dimension. So again, pretty cool tool, lets you get a sense of the data by poking around in it. So hopefully that adds some value. It's definitely worth taking a look at, especially if you're going to be doing this for real in a day-to-day basis. Something that you can quickly do some analysis on is useful. I did this for a work project to take a look at a simple way of doing some correlation testing to figure out if a couple things went together. It was a different sort of approach than what my coworkers were doing, so it was quite beneficial. So with that, I've talked quite a bit about this deliverable. If you have questions in particular, if there's something that I've glossed over or potentially didn't give enough clarity on, do feel free to reach out to me. That's what I'm here for. Stay safe. Also, if there's anything you're struggling with, let me know that as well so that I can tailor these discussions to that. Otherwise, I'll speak with you next week. So stay safe and good luck.